Alright, so our objective for today is to learn about acid bases and the pH scale. So throughout the week, we have been looking at water solubility. Now we're going to look at acids and bases. So by the end of this period, you should be able to answer the essential question, which is, what are the similarities and differences between acids and bases? Yesterday in your research, some of you probably saw in some of the research that pH may have something to do with solubility or not. Okay? So yesterday I kind of told you to ignore that. Can't remember if it was in this classroom or some of the other classes. But so today you will find out what acids and bases are. So basically, both of those are everywhere. They're in your food, they're in your house, they're inside of you. Okay? Right now, think of times that you've heard of the word acid or base. Okay, acid or base. Either or. Who can tell me an instance that you've heard of something, be it acid or base, or you've heard the word, and when? Jose?
Citric acid.
I'm sorry?
Citric acid.
Citric acid. Do you know what that does, or have you just heard the word?
It's like lemon.
Okay, it's in like lemons. Very good. All right, I've heard. Okay, we'll come back to you. Huh? Okay, Eric? I'm sorry? What about baking soda? It's a base. So all around you have acids and you have bases. Have you ever heard of people having acid reflux? Okay? And what happens to people that have acid reflux? What happens to your Devon? He drinks Alka-Seltzer. Has he, and he does. Has he ever described to you what that feels like? Okay, it's in his throat. Does he say that it burns? No? Okay, well basically it does, because I do have it. Alright, basically acid reflux is the acids that are in your stomach, because you have acid in your stomach. You actually have acid in your stomach that if I took that acid out and I put it on the table, it would actually start eating through the table.
So why is
It would
we have mucus in our stomach.
Listen. Alright. So it really would start eating, not necessarily what I put in there's a hole, but it would start eating away at the table. It's that strong of an acid. Now, the reason why you don't have hole, it goes through your stomach and to your intestines and so on, okay, is because your stomach has a mucus lining. Okay, your stomach secretes a lining of mucus. Mucus, mucal, okay, the snot that comes out of your nose. This is similar to that. Alright? So that mucus is basically covering the interior wall of your stomach. So since it covers that interior wall, it protects it from the acid. Now, people that have acid reflux, what they do is they have too much acid for some reason. Okay? And reflux basically means that it comes up from the stomach into their esophagus and so on. And they'll tell you that it kind of burns. The reason it's burning is because it's acid burning away at the inside of your esophagus, which doesn't have as much mucus as your stomach does, so it hurts. I'm sure you've heard of people that have ulcers.
Oh yeah.
Okay? An ulcer is basically a little hole. That little hole is made because of the acid. They're eating too much acid, and that lining isn't enough, so they start eating away and starts making a little hole. Well, if that hole bursts, that acid goes into the interior system and it starts eating away at their internal organs and so on. So whenever something like that happens, they have to go in and do surgery and basically clean all that off, soak all that acid off and put a base to neutralize it. Because if not, it basically eats away at the different parts of the different organs. So acids are important in your body because that's the way you are able to break down all your food and digest. But at the same time, you don't want too much of it because it can also hurt you. Jesus.
Where do they put it after surgery? Like, do they put it in a certain container?
Yeah, they neutralize it. They put an acid on it. Mariana said her dad basically takes Alka-Seltzer, right? Alka-Seltzer is a base. So what we're going to see is that whenever we take a base and we mix it with an acid, it neutralizes it and it makes it less acidic. And we're going to see why. Yes?
So why can't they take the stomach acid? But like, does the mucus stop the acid from burning through?
It does, but if you have too much of it, the mucus can only do so much. Okay, it's like a barrier. Well, if I have a barrier that's this thick, and this barrier can withstand a certain amount of acid, and as it breaks away, more mucus comes in. But let's say, because I do this a lot, I love tomatoes, I eat a lot of tomatoes, I eat a lot of ketchup, but basically I have some type of tomato soup or paste or something made out of tomatoes every single day. I love tomatoes, okay? I love lime, lemons, okay? Orange juice, I drink orange juice every morning, okay? So if I spend my time drinking and eating things that are very acidic all the time, well then, obviously, I'm going to have more acid than I need in my system, and my system isn't going to be able to make or keep up with the making of mucus because I'm eating too much.
Also, mucus comes back as it.
Yes. As the mucus gets broken into, your body makes more and it builds it back up. But if you're eating more than you should, it's not allowing your body to make up that mucus that is being broken into. That's when you start getting ulcers. Okay? Alright, so basically everybody kind of has an idea of what acids and bases are, right? Alright, so let's look at what an acid is. Okay? Go right in. Okay, so if we look at this, an acid is just a solution with an excess of hydrogen ions. So we know hydrogen is, right? Hydrogen's in group 1. Okay? It gives up a valence electron, or actually shares a valence electron, in order to bond. It's a positive ion, H+, because it only has one and it wants to give away instead of take, correct? Alright. Now, the more H+ ions, or hydrogen ions, there are in a solution, or a substance, the more acidic it is. Okay? So, together, let's think about it. Out of that slide, what are the most important things that I should write? Jose, what do you think we should write?
Excess of H plus ions.
Okay, so an acid is an excess of H+ ions. And what is H+ again? Do we all know? Hydrogen ions, right? Hydrogen ions. So, I would agree. I would just write that. An acid is an excess of hydrogen ions. Now, there's one more thing that's probably important on that slide about those hydrogen ions and about acidity. The more you have,
the more sour it is.
the more sour it is, the more acid it is. Okay? So, do you see how whenever you're looking at these, you shouldn't be writing all of it. You should, out of that slide, I would write 2 phrases. The phrase would be that an acid is a solution that has a lot of hydrogen ions. I wouldn't even use the word excess, I would say a lot. Okay? And that the more hydrogen ions I have, the more acid it is. That's it. The reason I'm doing this is because I saw some of your notes. You got a lot of stuff that you're writing, and I don't think it was necessary. Okay? So, let's look at the properties of an acid. So if we think of acids, here are some examples of some acids. Sorbic acid, which is actually vitamin C, it's in oranges. I drink that every morning. Okay? Citric acid, which is basically your limes and your lemons and stuff. Okay? Everybody, I'm sure, at one point in time or another, eat vinegar in your salads, or like my grandmother puts vinegar in the tomato sauce, so we're putting some more in there. Tomato sauce to make our soups and stuff. If you drink anything that's carbonated, Coke, Dr. Pepper, anything that has carbonation in it, that's acidic. Okay? And then tea. Tea is healthy, but it is an acid, so if you drink too much of it, it's bad too. So, if you think about all these, most all these taste sour, don't they? So, well, if you put sugar on it, that's a different story, but just by themselves, it's that they're actually sour. So, an acid, bless you, the property of an acid is that it's sour. Do you think that's important?
Yes.
I should write that down. Okay? It conducts electricity. So that's a property of an acid. So if I want to create something and I want it to conduct electricity, then obviously I'm going to use compounds that are acidic because they conduct electricity. So do you think we should write that down? Yeah, it tells us what an acid is. Because remember, our essential question is to differentiate between a acid and a base. How are they similar? How are they the same? So should we know the properties to see which ones are similar and different? That's why we're writing these down. So corrosive, which means they break down certain substances. Many acids can corrode fabric, skin, and paper. So that's a big word. What does corrosive mean?
Strong.
Okay, not necessarily strong. Eric. They break down. Okay, remember I said if I take some acid out of your stomach and I put it on this table, it's going to start eating away at it. Okay, that's what corrosive means, is that it breaks down materials. Now, it's not this. Whenever we remember we talked about physical and chemical changes, and we said breaking down was a physical change. If I take a piece of rock and I break it into pieces, it's physical, right? But when we talk about acid, when we use breaking down with acid, we're talking about breaking down chemical bonds. So if I break a chemical bond, is that a physical change or a chemical change? Chemical change. So when we're talking about corrosive and breaking down, when we say about an acid breaks down things, and that's a chemical change. So when something breaks in half, that's physical. But when an acid breaks it down, then that's chemical, because the breaking down is the breaking down of bonds. Okay? Some acids react strongly with metals, and they turn blue when you use litmus paper. Litmus paper is just a test paper. Okay? So if I use a red litmus paper, if I stick it in there and it turns blue, then I know I have an acid. And we're going to do a little activity on Monday where you're actually going to use litmus paper and see what happens. Okay, you'll see the different colors. I'm sorry? I'm sorry. Blue litmus paper into red. If the other one's the base. Alright, so all these properties are properties of an acid. Okay? Since our essential question is to differentiate between this and a base, then we probably need to write it down. So out of any of those, are there any questions? Everybody in here understands that corrosive means that it breaks down, but it's breaking down chemically, not physically. Okay? Alright. So, what do you use acids for? We already talked about vinegar, lemons, vitamin C. All those different things are acids. Your car batteries, or even your batteries that you have in your phones and your iPads, they have an acid in there. That's why they tell you that you shouldn't be just throwing out batteries in the trash can. Because basically you're throwing out a little canister of acid. So when you throw that out and it goes into the garbage can, and then they go in and put it into a big hole, and then they cover it up, and then you can go, oh, it's gone. It's not gone. Because remember we talked about how it rains and that rain goes through that trash and then it goes into an aquifer? That battery eventually corrodes, breaks down, and that casing breaks down. So when it breaks, all the acid's out. When that rainwater comes through that area and it takes that acid with it, now that acid is in your drinking water. That's why you're not supposed to throw out batteries in the trash can. You're supposed to take them to a recycling area where they take those batteries and very carefully take that acid out, and actually it ends up being reused for a new battery. So those are the things that you want to kind of keep in mind that most people don't think about. They throw batteries in the trash can all the time. Okay? Yes?
On the news the other day, they were talking about how, like, it's very similar to the water that was coming out. You put, like, a one to it with a person.
And it's probably because somebody put something in our trash system or the water system that doesn't need to be there. Yes?
What happened that the car battery popped on him, but he got out to the place, but it didn't use the water in it for like, how wild was that? And it didn't, like, eat his skin. Like,
Well, wait a minute, but see, what you need to think about is the battery is encased with another one, because it has water to cool it down. So it's encased in two different, like there's a case of acid, from what I remember. It's a case of acid, and then there's a case of cooling liquid, okay, just to cool the battery down, just like your car has the coolant that goes through it. So what probably spilled on them wasn't the battery acid, it was the actual coolant.
Because they popped that, like, the battery split in half and everything came out, and they failed.
It was probably the coolant, I don't think it wouldn't have been the acid, because if it's acid, now I'm not saying that it's so strong that it's gonna eat away at its skin, but it would have at least burned a little bit, itched. If it didn't, then it wasn't the acid that got on it, it was probably the coolant.
Maybe it's not so something.
He was itching, then it was the acid.
Yeah.
Okay, since that acid isn't as, to the point of eating a hole through immediate. It's not like hydrochloric acid. Hydrochloric acid, if I brought hydrochloric acid in here and I dropped like concentrated on this table, it will eat a hole through that table.
That's one
Then
reason
your hand, if you got it on your arm, it would literally eat through your skin. You would see it eating through your skin if it's concentrated in hydrochloric acid.
Just like when you drop the little metal piece and it makes a hole in the ground.
Have you ever seen the movie Aliens?
Oh, yeah.
And the blood, it basically would do that. Yes.
So like from G.I. Joe when she starts eating everything?
I've never seen J.I.
No, it starts eating away the Eiffel Tower, like.
Okay, and yes,
Oh.
it's acid. Yes.
Like,
You can
like,
fall on
no,
the-
I think that was like Breaking Bad, that they had the containers.
I've never seen Breaking Bad.
No.
But if any type of movie or program, you know I'm talking, so that means you're supposed to be tracking me. Okay? Any movie show, anything that you see that they use a liquid and that liquid's eating away through tables or through skin, it's an acid. That's what it is. Yes. Yes, because it starts breaking away the different chemical bonds. So because it starts breaking away the bonds, it basically eats away at the object. Yes. Glass. It won't eat away through glass for the most part. Yeah. The composition of glass is stronger than the acidity of it. So
They use it as a container.
yeah, glass is what is used as a container.
Is it stronger than any acid? Acid?
Yes, any strong acid will be held by glass.
Ooh, okay.
We should make our skin out of it.
Alright, sorry.
We should make our skin out of
I
it.
guess so. Alright, so we've already talked about acids, now we're going to the other side, which is the base. Okay, so looking at a base, says a base is a solution that it has an excess of OH minus ions. OH minus is actually called hydroxide ions. OH minus is called hydroxide. The name is hydroxide. So a base solution has hydroxide ions. Another word for a base is also an alkali. But we usually don't, well, I tend not to use it, but you will in chemistry. So anytime you see the word alkali, it really refers to something that is a base. If they say, oh, it's alkaline, it's a base. Bases are substances that can accept hydrogen ions. So look, OH minus and H plus is a positive. So it wants the H plus, right?
Because it cancels out.
Because they cancel out. So now think about it. If I have OH minus and I have H plus and they join, what did they just make? Water. Wouldn't it be two H's and one O? Is it two H's and one O water?
But it don't matter about the symbol though?
Huh?
It don't matter about the symbol? Like
Well,
then-
positive and negative cancel each other out. There is no symbol.
So then they'll become O and that's it, right?
Yeah, you have H2O.
Also, if you put a base,
What?
if you put
Yeah.
a base and a acid, they make water.
This one?
Oh, that's why it neutralizes it.
Yes. Yes. Very good. Aaron, so can you repeat what Ann said? Because that's very important. So you should have been tracking it.
Yeah.
The base that has the OH negative ions, it accepts the hydrogen ions because it's positive, they both cancel out and forms water, and that's why it neutralizes.
Very good.
You forgot that.
Oh, so it goes.
Yes, yes, so an acid and a base neutralize each other because when they come together, they make water. Okay? Ah. So, now let's look at the properties of a base. These feel slippery. They're bitter, so now they're not sour, they're bitter, the opposite end. Okay?
You wanna taste it?
Well, you do taste them, and then we'll talk about that as well. Okay? They're corrosive, so they're also corrosive. So a strong base can also eat through the tape.
What?
Okay? So the extreme opposite can also eat through the tape. Okay? They can conduct electricity. The alkaline batteries have a base in them, not an acid. Okay?
Which one?
You know how whenever you go buy batteries, someone say alkaline?
Oh, yeah.
Think about it. Alkaline is a base.
Okay.
So those batteries are a base. Yes.
No, it's better. Pipe.
They're just different. Yeah, they're different. Have you heard of lithium batteries?
Oh, yeah.
Okay. Look at lithium. Lithium's in group 1. So is it a positive or is it a negative?
Positive.
So if it's a positive, is it an acid or is it a base?
Acid.
Acid. Okay.
Wait, that's how it works?
So these.
Yes, that's how it works.
So from 13 on, they're all bases?
They would be making bases if they're have those properties. Yes.
Wait,
So smart.
so
Okay.
it's negative? It's base.
A base, yes, because OH negative. It's a negative. It's a
What's
base.
it?
So yes, Jesus.
So basically, the acid and the base are like total opposites. of each other.
Yes. Acid and base are total opposite. Okay? So, they also, but these do not react with metals. So they don't react with metals. And they turn red litmus paper blue. So, it's opposite. Okay? So for the most part, they're opposite, but they do have some similarities. So what are the similarities?
Yeah, they're
Conducts electricity and
corrosive.
they're corrosive.
Oh,
Okay.
They both eat through stuff.
So they both
And aren't they bitter as well? 'Cause they're sour?
No, these are bitter.
Wait, I mean, what's
The others are sour.
Oh, yeah.
Sour and bitter are two opposites.
Okay.
So when you mix an acid with a base, it makes water?
Yes.
So if you
Oh, my.
taste it, so if the difference in acid,
I said it wrong.
would that make?
One of the results is going to be water. One of the products. Alright, so things that we know are bases are things like soaps, ammonia, most of your cleaning products are bases. Okay, most of your cleaning products are bases. And the reason for it is because hydroxide ions interact very strongly with substances such as dirt and grease. So because they react with them, they break them apart because they're corrosive. So they break them apart and you're able to clean them off. Okay? Your blood is a basic solution. Your blood is basically a base. It's not a very, very strong base if I can recall correctly. But, excuse me, it's a base. So in your body you have both acids and bases. Your blood is a basic solution. Your stomach acids are an acidic solution. Yes.
What if like the blood and the acid
They neutralize and make water.
So blood turns into water?
Well, you have a lot of water in your body anyway, so it really doesn't matter. Alright, now, when we look at acids and bases, we have to have a way to measure how strong, how weak they are. The pH scale is the scale we use to measure acids and bases. That's what we use. So the pH scale tells us if it is an acid or if it is a base. Okay? The pH scale is from 0 to 14. So if we look at this scale right here, it has 0 at the top, 14 at the bottom. Okay? Acidic solutions are below 7. So if it's 7 or below, it's an acid. If it's 7 or below, it's an acid. If it's 7 or above, it's a base. Yes.
So milk is an
Yeah, a very weak acid. Because you have weak acids and strong and strong.
So closer to 7 you are,
Go, say again.
so the closer to 7 you are, the less.
The weaker you are, yes. So, since 7 is the middle, anything close to 7 is a weak acid or weak base.
Water here?
Okay? Water is considered a weak acid and a weak base. So, because it's
Because that's
neutral.
what they make when they.
Okay, because that's what they make when they get together. Alright? 0 is a very strong acid.
Hot sauce.
14 is a very strong base. Okay? So if you look, hydrochloric acid, which is the acid I told you that if I put on this table, you will see a hole on that table. Okay? That's a 0. It's one of the strongest acids out there. Okay? Drain cleaner. Drano. If you ever seen the instructions for Drano, it tells you, make sure it's a ventilated area. Okay? Make sure you don't touch it. Okay? And whenever you put it in there, you don't just put it in there. You put it in there and then you need to make sure water is running for a certain amount of time. Because, yes, it's going to break down whatever's in your drain that's clogging it up. But you also want to put a bunch of water in it to decrease how strong it is as it eventually gets into the sewer system. Okay? So if you look at that, you see that we use most of this stuff that's up here. Okay? Obviously, we already said water is neutral. Blood, like I told you, it is a base, but it's a very weak base. It's pretty close to water. Okay? Which that's in your body. Your acid in your stomach, if I believe, it's sorta in the 2-3 range.
What?
1, 2, 3, somewhere in there.
What?
Your acid in your stomach.
Oh.
So that's another strong.
It's a pretty strong acid, yes.
So what basically, what's that acid? Is it what is it?
What is that acid?
Is that what the picture?
The acid in your stomach? Gastric acid. They just call it gastric acid.
What is that a picture of?
What is a stronger acid than what? That is the strongest acid.
What is
Is
it?
it the more that's strong?
Okay. Yeah, no, because hydrochloric acid is 0.
What
There's
is
no
it?
negative numbers here.
Oh.
There's a 0, 14.
Is there anything other that's zero?
I believe so. I can't recall exactly the names of the acids, but there are several other acids in that same category.
So is that what is that?
I think sulfuric acid is also.
Is that acid what's in us or what?
No, you don't have hydrochloric acid.
What's acid?
It's just gastric acid. I don't know the exact formula for it, so I can't tell you. I'm sorry?
Two different foods that we eat.
Yes, and also your body just makes it.
So they're same acid or different acids?
In your stomach,
Yeah,
it's just one acid.
it's one acid.
Yeah, it's one type.
So from the different foods, they give us different
Well,
acids?
No. Your body makes a specific acid in your stomach.
Oh, okay.
But when you eat, like when I eat lemon, I'm ingesting citric acid. So I'm putting more acid in there. It's a different type, but it's still acid.
And it makes it into the one acid.
Well, it doesn't make it into it, but I'm just adding more acid, so that new acid is also eating away at my wall.
So,
Yes.
Okay, so gastric acid is up there with 2 and 3. How come lemon doesn't like burn gastric acid?
It does. Have you ever just left lemon on you? No, you cleaned it off. That's why I said it would eventually eat through it would eat through it.
So you just have to put the lemon there, but
It would start, yeah. Now, it would never make a hole through it. It's not that strong.
So,
But it would start. It is breaking down some of
That's why it
some
like
of
breaks
the.
down.
so does that lemon thing on the
Yeah. Have you ever seen? That's a perfect example. Have you ever? The dentist has ever told? They've never told you not to eat lemons just like this because I eat them, and they've told. And basically, the lemon's eating away at your
Enamel.
at
So
your
what
mouth.
keeps the
So
lemon?
it still eats away at it. It's just very slow. It's not like you're gonna see a hole there the next day. Yes.
You want to see.
Lemon, yeah. Yeah, you can lose teeth because of eating too much lemon or too much anything that's
Apples.
acidic. You can start hurting yourself. Yes,
So say if you add any type of acid and they come together, they just form
a strong
an
acid.
acid.
Yes.
So the covering on that lemon that keeps it from burning through?
Pretty much.
What is it made
The,
of?
have you ever tasted the covering of a lemon?
Yeah.
It's bitter.
Oh, okay.
Oh.
That makes more sense. Like on orange.
Yeah, it's bitter, aren't the coverings bitter? Okay, so the coverings are bitter and the insides is acid. So why does the acid not, because it's a base.
Oh,
But
okay.
why
And
do we
they
put stuff
neutralize.
out?
I've eaten both at the same time.
Yes.
You need help?
Because they'll eat it.
Well, basically with the apple, when they tell you that, it's because you're eating and you're basically your nutrients are going in. Plus, when your teeth are being used in a specific way, especially in a hard apple, you're taking away certain like bacteria and things like that. It's from what I understood, but I'm not.
So basically,
Yes. Yes. All peppers are acidic.
So, Miss Hernandez.
Yes. Question.
She says her aunt gets lemon drops and puts cinnamon drops.
Well,
Makes sense.
that must
So,
hurt.
isn't it-
Yes.
So basically, apples are good for us, but they also give us acids.
Yes. Now, guys, listen real quick. Obviously, we saw those foods on there, and they tell you that they're healthy because they are healthy. You want vitamin C. What you need to realize is that everything you come in contact with, for the most part, in excess, when you get too much of it, is when it's bad. Okay? You should eat apples. You should eat limes, lemons. So you should still eat those acids because they also have nutrients that you need. The problem is if you eat it in excess. Example myself. I'm seriously, I can technically eat ketchup just by itself. I can't, like, especially the Whataburger ketchup.
why what?
The Whataburger ketchup.
Oh, that's good.
Okay?
I'm just
So,
thinking like
That is going to an excess, and that's why I have to take
Put it in the cup.
medicine to make sure that I don't feel bad whenever I'm eating. Alright? So that's what you need to think about is everything on there is an acid and base. Everything on there is good, but it's also bad in excess.
Does it become a disease as you eat more and more?
Well, it's not a disease. It can become a disease because of the fact that your body can't deal with it anymore. Okay, so here's your gastric contents. I just wanted to show you this one. We don't need to talk about that. Gastric contents, a 2 and a 3, right in there. Okay? So what you need to make sure that you realize is that when you think of a pH scale, you always think of 7 as water, which is neutral. Okay? Strong acids are closer to 0. Strong bases are closer to 14. Okay? Question.
I have a question. Is because of the acid, why we burn? Then, like, say we drink Coke, then we burp, and
No, that has to do with gas.
that's like acid. It makes gas and burp.
Now that has to do with gas. Alright, so we already talked about acid and base reacting with each other, and that's called neutralization. The reason for it is because OH is negative, H is positive, the negative and the positive attract, and they make one. Okay? So, any questions over acids and bases? We're going to continue to work on acids and bases on Monday when we actually have a lab. I'm going to have several acids and bases, not anything strong. Okay? And you'll be able to test it and look at pH scale and so on. Okay? Any other questions? Yes?
It's kind of off, but isn't it ketchup like, isn't there two acids, like, isn't there citric from the, like, tomatoes or something?
Yes.
And
And then we put another acid in there, yes. So that's why I should be eating them, but I can't help myself.
Whatever kid is good though.
So, you have about 20 minutes left in class. The last 20 minutes of class, you need to be working on your special assignment. By the end of this period, you should know what you're doing. You should have your procedure done. And you should have a material list for me if I need to get you anything. Okay? So, right now, go ahead and get your stuff together and move to your groups.